Being able to identify where the vertex of a parabola is very useful. When a quadratic function is given to us in general form, it'd be nice to have a formula to be able to identify where the vertex is. And it turns out there is such a formula. The process of coming up with that formula involves completing the square of this expression, but once we do that, we can easily identify what the x-coordinate is, and it turns out the x-coordinate is given to us by negative b divided by 2a. And we could come up with a corresponding formula for the y-coordinate involving the letters a, b, and c, but it's just a lot simpler to take the x-coordinate that we can find very easily. This is a pretty simple formula, and once we find that number, we can plug it into the function to find the y-coordinate. So the vertex has the coordinates negative b divided by 2a. That's the thing that's important to remember. And then once you have that number, we can plug that in to the function to find the corresponding y-coordinate. So let's take a look at an example where we can see how this is a useful thing. So we're working with the function x squared plus 4x minus 12. And we want to identify whether it has a maximum or minimum, and then there's a whole bunch of other stuff that we can find out about the function. We'll talk about it in a moment as we look at it, but the axis of symmetry is one thing, the domain and the range, and the x and y intercepts we can find from the formula for the function. So to get started, let's identify whether we have a maximum or a minimum, and that comes from looking at the value for a. In this case, a is simply equal to positive 1, which tells me that the function is going to open upward. The graph might not quite look like this, but I know it's going to be an upward opening parabola, and so we end up with a minimum at the vertex. To identify what the minimum value is and where it occurs, we need to find the vertex. And so that's where our vertex formula can come in. So the value of b we can see is positive 4. And so if I plug that in, there's a minus sign as part of the formula, minus 4 over 2 times 1. So that simplifies to just negative 2. So the x-coordinate of the vertex is negative 2. And if we plug that into the function, I get negative 2 squared plus 4 times negative 2 minus 12. So we end up with a positive 4 minus 8 and minus 12, which gives us negative 16. And so the vertex has coordinates negative 2 and negative 16. And now to specifically talk about the minimum, the minimum value is the y-coordinate of the vertex. And we typically describe where things occur using the x-coordinate. So to kind of write a concluding statement for this, we could say something to the effect of f has a minimum value of negative 16 when x equals negative 2. And that's, of course, reflected in the graph of the function. So, we can sketch a graph now that we know what the vertex is, and we know that it opens upward. So the vertex is down here at negative 2 for x, negative 16 for y, so I can put a point down in the third quadrant. And we know it opens upward. So the graph looks a little something like that, roughly. And okay, let's think about the other information that we can find. The axis of symmetry, a parabola has an important characteristic. It's symmetric around the vertical line that passes through the vertex, meaning that what appears on the graph on the right side of that vertical line is the mirror image of what appears on the left side. Right? So there's a nice symmetry in a parabola across the axis of symmetry, across that vertical line through the vertex. And so to describe that vertical line, we can use the x-coordinate of the vertex And the equation for that vertical line is x equals -2, because every point on that line has an x coordinate of -2. Also, knowing the vertex, we can identify the domain and the range. The domain is pretty straightforward because the domain for every quadratic function is just going to be all real numbers, -infinity to infinity. The range, though, I do need the vertex. Knowing that -16 is a minimum value, the range is going to be from -16, including -16, to infinity. If this were a parabola that opened downward, the y-coordinate of the vertex would represent a maximum, and so -infinity to that maximum would be our range. And lastly, let's think about the x and the y intercepts. In general, the y-intercept is going to be easier to find. We can simply plug in x equals 0 into the function, and the function value, if I plug in 0, the x squared term and the x term are going to go away, and the value of c, negative 12, is going to be where our y-intercept is. So 0, -12. So this point here on our graph occurs at -12. For the x-intercepts, I want to, x-intercepts occur when y equals 0. So that means that our function f of x has to equal 0. The values that come out of the function have to equal 0. So we have to solve the equation x squared plus 4x minus 12 equals 0. Fortunately, this is a pretty straightforward equation to solve. We can factor to come up with an answer. If we didn't see that this factors as x plus 6 times x minus 2, we could use the quadratic formula because it is a quadratic equation. So it turns out the x-intercepts occur when x equals -6 and when x equals +2. And we can see those on the graph. So this point corresponds to +2, x equals +2. And this point would be the value when x equals -6. So there's a lot of information that we can find about the graph of a quadratic function from its coefficients. I hope you enjoyed the video. Thanks for watching.